Okay, here is our Unit 2 test review. In this first section, we are being asked to do operations on two given functions. Remember that when you see f parentheses x, it doesn't mean f times x. It means the function with the name f and the independent variable x, and we read this as f of x. So in the instructions, I have that f of x equals x minus 5. So since they are equal to each other, wherever I see f of x, I'm going to replace it with x minus 5. And then plus g of x, which I know equals x squared minus 1. So I replace this notation g of x with its function that it's equal to, x squared plus 1. And then I combine any like terms. And the x's are not like terms because their exponents don't match. But negative 5 and 1 are like terms, so I can combine those. So if I write them with the exponents in descending order, I have x squared plus x minus 4. For subtraction, this time I'm starting with the g function first, so x squared plus 1, minus the f function, which was x minus 5. And because I'm subtracting off two things, the x and the minus 5, that whole group is being subtracted. That means to take the opposite of each one. So this becomes minus x and minus negative 5, which is a positive 5. And then I still have the x squared plus 1 from above. Combining like terms means combining 1 and 5, so I have x squared minus x plus 6. When we go to multiply the functions, f of x is x minus 5, g of x, x squared plus 1. This is a FOIL situation. I'm going to take this first x and distribute it in. Sometimes we call this double distributive property because we're distributing twice. And then distribute the negative 5. There are no like terms to combine, but if I were writing the exponents in descending order, it would look like this. And then for this last one, we have a division, a fraction, or I should say a division in fraction form. So the g function goes on top and the f function on bottom. Remember, we can't simplify because the x squared is being bound to the 1 with the addition, and the x on the bottom is bound to the 5 with subtraction. So we don't cancel. Those are called terms. Terms are things being added or subtracted. We can only simplify or cancel factors, which are things being multiplied. So there's actually no simplifying we can do here. If I'd had this instead, where the terms are being multiplied, so they're now factors, then I could simplify an x here and finish my answer, but the addition or subtraction means I cannot. That groups the terms together in a grouping, and you can only cancel them in a group now, not individually. So if you haven't read through number 5, I want you to pause your video and do that now so you can get an idea of what it says before I talk about it. All right, so I'm going to start right here. You are purchasing a camera for $299.99 after signing up for their email list. How much will the camera be after first getting the 5% off, then an extra 20% off? So we're going to create a function where x represents the price of the camera, and then after I set up my function, I'll plug in the $299. So the first thing that's going to be happening to my price is I'm getting 5% off. If you're taking 5% off, then the amount you're paying is 95%. And we write that as a decimal as 0.95. So this is the number I'm going to use in my function. So we're first going to do 0.95 times the cost of the camera. Then we're going to take off an extra $20. So now I'm going to use the specific cost, $299.99. So I'm going to do 0.95 times that value. You'll have a blue calculator on your test, so you'll do this on your calculator, find that number, then subtract 20, and you'll come out with about $265. This next section is for composition of functions, and I want to take a second to talk about the difference between this notation with the open circle and this notation with the closed. A closed circle means you're multiplying. An open circle means you're plugging one function into another function. So I'm taking, or let me write this a different way. This also can be rewritten as this. These are equivalent symbols. So this is saying you're taking the entire function g of x and plugging it into f wherever there's an x. Remember, just like if you had f of 5, this means take 5 and plug it into the x in the f function and simplify it, right? So that would be 5 squared plus 3. Well, this just means instead of a number, you're plugging in an entire function into another function, and that's what we call a composition of functions. So it means take g and plug it into f. So g is x minus 1. I'm going to plug it into this x value right there. So x minus 1 parentheses squared plus 3. Notice I put parentheses around that because this entire thing that I'm plugging in, which is an expression, x minus 1 as a grouping, that entire thing is being squared. And you can actually leave this as your answer if you like, or if we expand it, x minus 1 squared means x minus 1 times itself. That's a FOIL situation, which would give me this. Then combine the 1 and the 3. So I would take this answer or this answer. I'm going to have you pause your video and try the next one, but first let's talk about what it's saying. Here you'll notice both functions are g. So you're still going to start here and do the outside one last. So here you're going to find g of negative 1. You're going to take negative 1 and plug it into the g function. Actually, I'll just do this for you. G of negative 1 means plug negative 1 in for the x. So g of negative 1 equals negative 2. Now that I have that, I'm going to plug it into g again. If there had been an f here, I would be taking negative 2 and plugging it into the f function for x. But it's telling me to plug it into g again. So now g of negative 2 is equal to negative 2 minus 1, which is negative 3. And that is called composition of functions when you take one function and plug it into another one. On the back here, we are doing composition again to verify if two functions are inverses of each other. So the way I taught that was you want to find both f of g of x and g of f of x and see if they both simplify to x. If they both simplify to x, then you would say yes, they are inverses. So I'm going to start by taking the g function, plugging it into f. So g was 1/3 x plus 1. I'm taking all of this and plugging it into this x right here. So since these are two terms being grouped together with an add, I'm going to put them in parentheses. Now I distribute this 3. 3 times a third is 1, times x is x. And 3 times 1 is 3. So this does not simplify to x. That's not an x variable. I was supposed to try to indicate that it did not pass, so it fails. Now I could stop here. If it fails one, you don't have to test the other, but just in case you tried testing the other, let me show you the math for that one. This one is saying to take f and plug it into g. So now I'm going to take 3x minus 1 and plug it for this x right here. So 1/3 parentheses 3x minus 1 plus 1. Notice because I have 3x minus 1, which is two terms being grouped together with a subtract, I put it in parentheses. It's a group. Then distribute the third. A third of 3 is 1. A third times negative 1 is negative third. And this is not going to simplify to just x, so that fails also. So this is no, not inverses. They would both have to simplify to x in order to say yes. Now this next section, we are testing symmetry for odd, even, or neither. Odd is another way of saying that it's symmetrical over the origin. Even is another way of saying it's symmetrical over the y-axis. So for the odd test, you're going to plug in negative x and negative y, simplify and see if it equals the original equation. For even, you're just going to plug in negative x only. All right, so here's my work from the key that I already have written. So a few things I want you to notice. First, I took the original equation, simplified this absolute value to just y. So after simplifying, the original equation is equal to just regular y plus x equals 10. So for our even test, which is testing for symmetry over the y-axis, we just plug in negative x wherever there's an x. So I put negative x there. I have absolute value of y minus x equals 10. The absolute value simplifies to just y. So y minus x equals 10 does not equal the original equation, so it fails the even test. The odd test is checking to see if it is symmetrical around the origin. That's where we're going to plug in both negative x and negative y to the original equation, which is what you see right here. I can't simplify negative x anymore, so it comes down, but I can simplify absolute value of negative y. It is y. So now I'm again at y minus x equals 10. Does not look like the simplified version of the original equation, so it fails that test also. So we would say that this is neither even or nor odd. And there's only one practice problem of this on your review. If you haven't done the practice problems for this lesson, I recommend you go do those so you can have more examples. This is not the only possible example. And then for this last section, we are being asked to find where the graph is increasing, decreasing, constant, and state where any local max or min are. So constant is when you have this horizontal line. Decreasing is just like if you were on a roller coaster going from left to right. Decreasing would be this section right here. And then increasing, just like if you're on a roller coaster, would be this section right here. So for the increasing, we're being asked to write the domain. So the left boundary to the right boundary is 2 to 3. The 2 has a parenthesis on it because at this point, these two sections are overlapping and they have different behavior. So we're not going to say it's increasing at 2 because how do we know to say it's not constant at 2? So when they're overlapping, we're just going to use a parenthesis. But notice where 3 is, it's at the end of the increasing interval and there's no overlap. So we're going to put a bracket there and say that 3 is included in the increasing section. And it's decreasing from x is -1 to x is +1. At both points, it's overlapping with another section that has different behavior. So that's why both of these have parentheses at -1 and +1. The graph is constant in 2 places, so I have the intervals for both of them joined with a U. -3 to -1 is the first interval. The first point is not overlapping with anything, so it has a bracket. The second point is overlapping, so it has parentheses, as well as these over here. Now this next one was the trickiest part. It says to state any local maximums or local minimums. It doesn't mean a max or a min, it means local. That's when the behavior changes from, a maximum changes from increasing to decreasing, and a local min changes from decreasing to increasing. Now we have maximum and minimum values, but they don't occur where this behavior is happening. So here's a maximum, but it's constant and then decreasing. We want it to be increasing and then decreasing. This is a minimum value right here, but it goes constant to increasing, not decreasing to increasing. So we say there's no local max or local min. There is a maximum and a minimum value, but we wouldn't call them local max or min.